This episode is sponsored by Magic Mind and Wix Studio.
When is the last time you listened to a podcast about web development, web design, and small business and didn't fall asleep? Yes, we cover web development, web design, and small business, but like actual human beings with personalities. If you're a beginner, we're not going to talk over your head. It's more like asking your buddy for help. We have guests, we have fun, and let me tell you, these two can get off on a tangent. Ladies and gentlemen, welcome to HTML All the Things Podcast. This is Matt Lawrence and Mike Curran.
That's right, everybody. We are back. This is the HTML All the Things Podcast. This episode is titled, What is Async JavaScript? This is actually inspired by someone who wrote in on htmlallthethings.com in our contact form, and we had a brief discussion, and they were interested in this topic. So thank you to that person, and I'll reach out to confirm and send over a link when the show is out. But if this sounds interesting to you and you want to support the show, you can go check us out on that Patreon, leave a review rating on your podcast app, join us in our Discord server, or share this with your friends. Now, a bit of an accelerated introduction there, because I think this is going to be a bit of a loaded episode, because we got some code examples and everything. I'm just flipping through here, because Mike actually put this episode together, because he would know more about this than me. So, please, sir, take it away.
Yeah, absolutely. And I think when the user wrote in to ask us about this, it was a very timely suggestion, because I believe that async JavaScript, although a lot of people use it, I don't think a lot of people use it to the full potential. And I'll explain as we're going through the episode. But essentially, there's many different ways you can define async JavaScript, use async JavaScript should be like more clear, but there's many different implementations that allow you to do things asynchronously, and I'll get into what asynchronously means, but people kind of tend to always go to the simplest solution. And the simplest solution, although great, isn't always the best, and I'll explain later in the episode. But first, I want to explain what is async in JavaScript. So first of all, JavaScript is a single-threaded language, okay? And what does that mean? That most, or if not all, of the execution of code happens on one core, one thread, or one like operation stack where your code is running top to bottom. So whatever you write at the top, it is going to run that, then it's going to run the next line, then it's going to run the next line, then it's going to run the next line, then it's going to run the next line until it gets to the very bottom of the stack, and then it's going to finish that program, whatever you wrote, right? So that's called synchronous operation. When it goes top to bottom, there's no, going to a different stack or whatever, like it's all just top to bottom. Now, where asynchronous starts to come in is when you have something that runs not just top to bottom, but you can have something that runs to the side, like something that runs on a different core, or something that runs at a different time frame, or something that runs in parallel to your current like call stack that's running, right? So if you have like an application that's running a hello world, for instance, you would have the first line be maybe declaring a variable, let A is equal to hello, and let maybe the second line being let B equals world, and then you would have something that puts them together, and then you would have a console log that displays that console log. So again, top to bottom, it would run it one line at a time. Whereas if you have something that is asynchronous, you could have a function that runs on maybe a timeout, or maybe it does an API call, and that runs unpredictably a lot of times, and that's why you want the asynchronous kind of approach to it. But it also could run in parallel to your official stack, right? So you can have the same example where you have hello world, but instead of having it run, top to bottom, you can have a promise where the promise will have a timeout in it that combines hello and world after 200 milliseconds, right? And then that promise will then also run the console.log. And so what happens there is if you have like set A to be hello, set B equal world, that's running synchronously. And then it runs technically synchronously the promise, but then the promise goes off on its own outside of the call stack and starts running whatever's in that promise, whether it be the 200 millisecond timeout, and then it actually displays the console log. So those are kind of two separate operations you can think about in two different call stacks. That's the high level, but like a little bit more intricate way of talking about asynchronous JavaScript and synchronous JavaScript. I think the big thing is why you use async, or one of the reasons is that async helps prevent blocking in the main thread. If you have an operation that is unpredictable, like I said, like an API call that could take 1 second, 2 minutes, 5 minutes, if you do it synchronously, what will happen is your application will literally freeze up for the time that that operation is running, whether, again, it'd be 1 to 10 minutes. And then after it's done, it would allow you to continue using that application. Whereas with asynchronous, what you can do is you can free up your application to continue to do whatever it needs to do while it waits for that operation to perform. And then when it performed, you can run some other stuff after it. You can detect when an operation is finished and run the following code, whatever you need to do after that operation is finished.
Well, and having things be asynchronous versus synchronous in this way, like, would really help with UX, I'd imagine, because it'd be pretty bad if your app was doing something like maybe managing the slider or something like that, managing some performance stuff, animating something, and it was using JavaScript to do so. And then the user obviously is on the site, has a bunch of buttons at their disposal, and they click on one of said buttons, and it tells JavaScript, yo, you got to do this. And it's like, all right, just hold on a minute while I, rearrange the slider or something along those lines. It's like the user is not going to know what's happening. And if it were to freeze up, it looks like it's broken. And if you had something where it's like, oh, I'll just have a loading screen or a please wait, having a bunch of please waits is not the greatest UX either.
Exactly. That's exactly it. And again, like, to reiterate, you want to avoid blocking operations on a website as much as possible. If you have a blocking operation on a website, what that means is that no one can actually click on any of your buttons. So if you have something that takes 200 milliseconds or 500 milliseconds or 5 minutes in a blocking operation using like synchronously, that means that when a user clicks on a button that has like a event listener to it, like on click event listener or something, some sort of action associated with it, it puts it in the queue, the event queue, but that event queue isn't going to be called until the stack is clear, which means that the blocked operation literally stops it from being called for potentially 5 minutes, which is obviously a terrible experience for users. So it's really important to understand the consequences of blocking JavaScript, right? The consequences of synchronous operation when you can do something asynchronously, and then understand the outcomes of actually doing that properly to be able to manage both kind of threads at the same time. I'm going to go through what we call the event loop in JavaScript really quickly. I don't think that this is something you need to get too hung up on, but I would kind of recommend going through and kind of understanding it on your own time as well, because again, in a podcast, there's only so much I can talk about in a more complex subject. There's better diagrams out there, and there's better explanations out there that you would have to like maybe play around with an example or two to understand fully if you want to dive deeper into the architecture of how JavaScript runs in your browser. But essentially, like I was mentioning, the event loop, there's a call stack, which again handles in synchronous operation. It's like a last in, first out manner. So whatever is put in, like in order, it's going to run top to bottom. There's also something called a task queue, which is something that a lot of asynchronous operations will use. It stores callback functions that are ready to be executed when something like the call stack is finished. So that's something where you can be like, I want to put an asynchronous operation in the callback queue, and that'll be executed whenever it's finished, right? There's also a micro task queue, which handles super high priority items like resolving promises. We'll get into promises shortly, don't worry. And then it goes back to the call stack queue once it's done resolving an important promise. And then there's the event loop. I mentioned the event loop when I talked about event listeners, right? So if you have a call, an on-click listener on a button, that would be continually checking that call. That's what the event loop is used for. It's continually checking if someone has pressed that button. When someone presses that button, it'll put that action into the call stack. Again, this isn't the greatest explanation of the event loop. I would highly recommend people go a little bit deeper into it, but I just wanted to provide an example of how a little bit more complicated JavaScript gets when you start talking about asynchronous, and why a lot of times we really rely on the simplest solution, even when it's not the best use case. And we should start to understand a little bit more about what, promises are and when to use the simple solution versus the complex solution, et cetera, et cetera.
I do want to say something too, is that this asynchronous stuff, it sounds super complicated and like it can get there, but it is something that you do stumble upon naturally when you start to code up applications. Like when you first start using JavaScript, at least to me, it was really everything kind of made sense. But then when things needed to be done in specific timings is when I started having to understand synchronous versus asynchronous and what was going on. Do I set a timeout here? What do I do? And that's because if you think about it, if you have two things that are going to happen, like let's say you need a number calculated and then you want to take that number and display it in a certain section of the screen, you have to wait for the number to be calculated before you push that number somewhere. Otherwise, the function, just in terms of functionality, is broken. And so you may not realize that maybe both of those things are being done together or like asynchronously. And then all of a sudden you're like, uh-oh, like it's trying to place something that doesn't exist and I'm getting an error now, where, okay, I need to wait for this thing to actually be calculated and then I need to display it. So maybe I need to do this, in your top to bottom, like do it synchronously, like go down, down the list it goes as it reads to calculate, now display it type thing. And that's just one really, really simple sort of off the cuff example that I'm giving just for the sake of an audio show. But once you get into coding up things that are a little bit more complicated or a little more multitask, or maybe multi-feature is a better way to describe it, a bit more multi-feature friendly or multi-feature required, then you'll start to realize like, oh, like I'm trying to display logs when that information isn't done cooking, right, in the code somewhere, or that timeout set to 3 seconds and this thing's running 2 seconds into it. So now that information may be, contaminated or might not be calculated to the final result. That's another example of something that can start messing things up. And so that is when you will naturally come to this async stuff.
Yeah, absolutely. I wouldn't dive into it too deep until you really need it, but it is a really important part of JavaScript that I would highly recommend learning before moving on to something like React, for instance, or something like, SvelteKit. Like it's just one of those fundamental aspects of JavaScript that you're going to stumble upon no matter what. As soon as you start calling data, you need asynchronous functions. And we all know that a lot of more complex websites are going to need data, some sort of data API layer or something like that. And it's just important to understand what's going on in that, the way that JavaScript operates, essentially. So I'm just going to go into the ways of handling async in JavaScript. And I'm going to go through kind of like almost the ways that I learned it top to bottom and the ways that it was implemented in JavaScript. So the first one I'm going to talk about is called callbacks. I want to caveat this with the fact that I haven't used the callback in years. And that's because of the next part of this discussion, which is promises. But I think callbacks are important to at least understand. If you're reviewing older code, you're going to probably see something like this. And B, sometimes it's just a really quick way to implement an async operation without having to wrap your head fully around promises. And it is a cool thing to have in your tool belt and an important aspect of programming in general. So what are callbacks? Essentially, a callback is a function that you pass in as an argument to another function, and then you intentionally run it after that function is finished executing. So a callback, usually you don't know what's going to be running in a callback function, like the function itself that's running it doesn't know what's going to happen in that callback function, but it will run something like, for instance, you have a data fetching call, right? So you have an API call, an Axios fetch request, whatever, just a regular XML HTTP request, and you have that run in a regular function. So function fetch data. After it runs, again, it runs, you want it to run asynchronously. You need something to run after it to inform your UI that something's changed, or send a message to the console log, or whatever, to be able to do something after a function runs without blocking the main thread. And the way to do that, or the older way to do that, was with a callback function. So you pass in a callback function, and then what happens is that callback function is put into the task queue, not the call stack. And therefore, the call stack is clear, so people can still click on a button on your website, but the callback function will run after the data fetch happens, and it will still provide whatever, console log that you need, or an alert message that you need that, hey, the function has received the data, and now you can update the UI in whatever way you see fit. The caveat with this is that as soon as you get past the first like really simple use case of a callback function, what can eventually end up happening is you get into something called callback hell, where, and I've had this before because this was the first way that I was introduced to asynchronous JavaScript. You have a function that relies on another function. And so you have a callback in one function, but then you have another function that relies on that function. And so you have this trickle down of callbacks and nested callbacks within callbacks within callbacks. And to manage that, like which callback runs first, which callback runs second, doable. And I've done it before, but it becomes very, very complicated really quickly. Okay, so you don't want to get into the habit of nesting callback functions. And in my opinion, honestly, again, with the introduction of promises into ES6, there's just no reason to fully rely on a callback other than knowing that they exist. Now, the next part, like I said, we're going to talk about promises. So promises were introduced into JavaScript not fairly recently. It's been a while now, but it wasn't like essentially they weren't around when we first started with JavaScript, or they weren't fully supported yet. So that's why I had to rely on callbacks. But when promises came around, everything kind of changed. Okay, so a promise in the same kind of form is a cleaner way to handle an asynchronous operation. And they represent a value that may be available now, in the future, or never. That's the most important part to understand with a promise. So a promise is a indeterministic value, essentially, that could, first of all, could never resolve. That's a rejected promise. It could resolve in an error. That's a catch for the promise. It could resolve fully and be fine, and it could be fulfilled. Or it could be in a state of pending, where it's obviously in the process of actually being resolved. Okay, so it's an ability to put a function in an indeterministic state until it becomes deterministic for you. And you can detect those states, you can do whatever you want with those states, and it's all running, again, asynchronously outside of the main call stack, which means, again, not blocking, really important, right? So in this case, a lot of times when you're doing something like a fetch data, you would wrap that fetch data into a promise, and then whenever that promise, that data resolves, however call you're doing, whatever API call you're doing, you will use a keyword called resolve and then send back that data to wherever you need to go, right? So a promise is a way to handle indeterministic operation, asynchronous operation, in a much more cleaner way. It has other functions associated with it. Like once a promise resolves, you can do a .then statement after it. And in that .then, essentially that is going to be triggered when a promise is done, when the resolve is hit. So you can do anything after a promise. And then you can also do a .catch right on that promise, which will then catch any errors that happen. So what happens if the API call doesn't work, breaks, right? What happens if your server goes down during the API call? A return a catch will happen where you can do a toast error message, right? You can put a console error, whatever you want. You can catch that. It's not going to break your application. That's really important too. This is not a breaking error unless you want it to break your application. It's up to you. But it's your ability to catch an error and do something intelligent with that error to provide the user with some feedback that, hey, something went wrong, maybe try again, whatever. So a promise is a really, really, really sophisticated way of doing complex async operations. Now, it can get a little bit hairy when you have promises that are nested within each other, again, but it's a lot more simple to understand than having callback hell, because they're kind of like just multiple .then statements within one promise, right? A little bit easier to read top to bottom without having to like, okay, where's this function going? Where's this function going? It's a little bit better to understand in that sense. But again, over nesting promises, that I still wouldn't recommend. That's something that like requires more of a rethink in how you're implementing that feature. You don't want to be relying on a million different aspects of, a million different nests to get your application built. There's other benefits of the promise infrastructure. There's promise helpers called promise.all, which will allow you to run many promises at the same time. And there's also a newer one that I don't know if it's fully supported by every browser. I think it is, or it almost is. It's called all settled, where essentially a promise.all, you can run many promises inside of it, but a promise.all settled will allow you to run many promises. But if one fails, it will continue to run the rest of the promises without breaking your promise.all and without reverting all of the operations. and just give you a return statement of which promises errored out, right? So it allows you to have a really good flexibility on, if you need it, on what promises were successfully fulfilled and what promises weren't. If you need your application to error out if one of all promises is errored, then you can use a .all. That's perfectly fine, and it's a very valid way of doing that. But there's a lot of flexibility with promises, and the main thing that I want you to take out is that you can do really complex parallel operations and parallel requests where you can utilize multiple threads to actually send out multiple API calls to different endpoints and have those happen at the same time rather than having to wait top to bottom if an asynchronous operation. And we'll get to the next part of this shortly, which is like the simpler route, but the one that you can get caught in the most.
So I do have a question here about whether or not promises and callbacks are relevant. Meaning, are promises replacing callbacks? Like, it sounds like when you mention callback hell, that it kind of sounds like, oh, there's this thing with callbacks. It's like the older way of doing things. You can get stuck in this thing called callback hell. Don't do that. Use promises. Is that factual, or is it no, callbacks are still relevant and you use them for this? Promises are relevant in these other cases. Devs, this one's for you. I've got 30 seconds to tell you about Wix Studio, the web platform for agencies and enterprises. So here are a few things you can do in 30 seconds or less on Studio. Integrate, extend, and write custom scripts in a VS Code-based IDE. Leverage zero setup dev, test, and production environments. Ship faster with an AI code assistant. And work with Wix headless APIs on any tech stack. Time's up, but the list keeps going. Step into Wix Studio and see for yourself. Link in the show description and in the show notes.
I tend to, like I said, when promises came into effect, however many years ago, I almost immediately stopped using callbacks. So like I haven't used a callback in so many years because of the fact that promises have essentially replaced all the functionality of a callback in a more robust, easier to implement package. So I think callbacks are mostly irrelevant. There might be some edge cases that I don't know about where callbacks are still relevant, but over the last 5 years, I would say, or 4 years, I haven't reached one of those edge cases.
Because I remember distinctly, I guess this is another question, actually, I should phrase it as, I don't know if you remember this, Mike, but this was right when promises were new-ish, and I was making like a mobile app that I was wrapping in Cordova, and I was new to JavaScript at the time. You had a bit more experience with it, and again, this is a number of years ago, and I was doing a bunch of stuff in this app, and I remember asking you, like, man, I don't know how to like confirm if this data's done, and like whatever, like I started getting into the complications of like things are running synchronously, asynchronously. I'm trying to time things, but I'm considering mobile devices, so I can't just reliably say, okay, this is going to take 2 seconds to compute. I'll set a set timeout or something like that. And so I started getting into this stuff, and you introduced me to callbacks. You're like, oh, okay, callbacks is what you want here. So my question is, like, with all that kind of as a base, how do people know to do this? Like, I knew when I was naturally going through it, which we've already mentioned in the show, is like you'll naturally kind of bump into synchronous, asynchronous, and if you start Googling things, people will start mentioning it in threads and comments and such, and you'll be like, oh, okay, things are running, synchronously, asynchronously. It's kind of all over the place here and there, and I got to kind of wrap my head around this because I've never done it before. But for whatever reason, the concept of a callback never kind of showed up at the time. Like no one had mentioned it in these forums or anything like that, and promises hadn't been mentioned either, but promises were just becoming relevant at the time, at least in our kind of knowledge bank, meaning our brain. So I guess the question is, like, when somebody starts bumping up into the asynchronous and synchronous things naturally, should they immediately start studying these topics? Or do you think that now with maybe promises kind of quote unquote replacing callbacks, do you think that there's a more natural path now where people will start saying, oh, you need to start doing promises, and they'll be more naturally led into it? Now, obviously, this is going to vary per person, per problem. And we're talking about, kind of general comments on forum posts. But I just want to know, like, because I wasn't pointed in the right direction until you told me. And I don't want someone else listening to this to kind of be like, oh, I'll wait till I'll naturally run into trouble. And then they'll be like, man, I'm now in trouble and don't know where to go.
Yeah, so it's become a lot more relevant these days than it was back then when we were building our first applications, right? When we were building our first applications, the web wasn't really an app platform. It was more of a web platform where there was a lot of websites, but apps were still native. Most apps were native, Windows, Mac OS, iOS, Android, whatever. And people didn't build these highly performant, highly complex web applications. And therefore, there just wasn't as much need for callbacks and promises and async await initially. That information was still available. It just was a little bit buried. But nowadays, as soon as you run into the situation of like, hey, my UI is blocking, or like my UI is freezing up whenever I, call a API or call some data, how do I fix that? That will immediately take you to an asynchronous solution. Now, might not be promises. The next one that I'm going to cover is called async await, and I think this is the most common way of handling asynchronous operations in JavaScript right now. And I'll get into why in a second, but I think there's just a lot more tools at our disposal that are a lot easier to find nowadays, where you are going to find those answers pretty quickly, whether it be through AI, whether it be through Google, whatever, as soon as you run into that issue. But again, I'd still recommend, if you're learning JavaScript, if you're new to JavaScript, I would recommend spending a little bit of time on async await, like on promises and async await and stuff in general, before you even might run into that situation, just so you know of these solutions as they come up. This is a very important aspect, again, of modern JavaScript when you're building more complex applications. You can't go without it. Like, it's not possible to not use it if you're building any web app out there. You need to understand how these work and where their limitations are, and then utilize the right tools for the job, kind of thing. It's the right tool for the job. Now, having said that, let's get into, again, number 3 here, which is async await, which is the most popular way to handle asynchronous operation in modern JavaScript today. The reason for that is what I mentioned right at the beginning of the episode. This is the simple way. So this way makes it look like you're running synchronous code. There's no weird wrapper for the promise that you have to wrap around and then add in a resolve keyword and a reject keyword. There's no weird, there's much less functionality of like having to fight a complex syntax, right? Now, promises and async await can actually work together in a lot of ways, but traditionally, a lot of times that's extrapolated for you. You don't have to worry about that because you're going to be implementing a package or something that's going to be available in async await form. Essentially, any sort of promise that has already been written, instead of having to catch it or do a dot then or have any sort of nested infrastructure of like running those promises, like, running a dot then and then another dot then, instead of doing that, you can actually do what's called an await. If a function is declared as an asynchronous function at the top level, so when you're declaring a function, you literally write async function fetch data, right? That's how you declare an asynchronous function. And if it's an asynchronous function, that means inside of it, you can use the keyword await to essentially await for a promise to resolve. Instead of doing a dot catch, which is the native behavior of a promise, or dot then, you just literally go await, let response equals await whatever promise that you have. And again, it could be a new promise that you write that you're just waiting for like a 200 millisecond timeout to resolve, or it can be a regular fetch statement, which is already a wrapper for a promise. So whenever you await a fetch statement, it'll actually automatically put that response into a variable that you can declare before it. So it feels like you're writing synchronous JavaScript because all you're doing is awaiting a promise. You're not doing any sort of weird dot thens, dot catches. But in reality, it's still performing an asynchronous operation. So when a promise is awaited, it will continue to be running in a separate event loop, in a separate call stack, like a task stack. and not block the main thread. So even though it looks synchronous, not synchronous, still not blocking, which is great, right? And you're able to write really simple asynchronous functions and use really simple asynchronous functions. And I think this is where, honestly, people fall into the habit of only using async await rather than using what promises allow you to do, which is doing multiple promises at the same time with a .all or .all settled and stuff like that, and utilizing some of the more complex functionality of a promise and upping their performance. Because multiple asynchronous promises, if you have, like, let's say a promise at the top where you're awaiting some data, right? And you're just awaiting that, whatever, the fetch data function. And then you have another one at the bottom that's awaiting other data about, like, irrelevant data to the first one. Okay, it's not reliant on the first one to be enacted. What happens is that first function will run and it'll wait for that data in a separate thread. So it's not going to block your application, but it'll wait for that data. Then the next part of that function will run, and then the next promise will run. And then it'll continue on from there. So it's running in a sort of synchronous form without blocking, but it's still running kind of synchronously. When you could just bundle those two promises together using a promise.all, both those functions, both those promises can go and get the data that they want at the same time, right? And then it'll continue on after both those promises have finished resolving, right? So you can save a little bit of time, a little bit of execution. This is extremely important, especially when you're doing serverless functions where time and execution matter. Essentially, in a platform like Netlify or Vercel, when you get to a larger application, every millisecond that a function is running actually goes against the cost of your platform. So the faster you can do things, the cheaper you can make that application. So bundling up different data calls, different API calls is going to save you not only time, but money. So it's important to understand that you're doing that. Now, this is one of those things you do want to reach for when you're ready to reach for it. Because again, a lot of times you're going to struggle understanding async await or struggle understanding with how asynchronous JavaScript works. So it's more important to just get it working, make sure that you're not blocking the main UI thread, and just use the easiest solution out there, which is async await. But when you want to go further into it, make sure to go back to promises a little, learn about what promise.all does, learn about what promise.all settled does, understand the differences, understand how you can utilize them to make your application perform better. And then you're going to be kind of a leveled up engineer at that point.
I have a question regarding async await. This is just my own personal take on this. Just looking at the example, we have some example code in our show notes, which will be on htmlthings.com in the show notes, of course. But I'm looking at this and it looks like, and it kind of sounded like, is this like a workaround that someone has come up with? Like, promises are very sort of like structured, which you mentioned, very structured, very like, okay, like this is how we want, people to kind of like, quote unquote, replace or have an alternative to callbacks. This async await, just again, this is my opinion, looking at the syntax, looks like someone has just like come up with a methodology and this isn't like an official thing. Is that what async await is ultimately?
Well, it is official, like it's part of JavaScript in that sense, but from one part of it, I do agree with you. I think this is someone that came up with it that's like, I hate writing promises because I'm used to writing regular JavaScript. And he provided this kind of hacky-ish way of doing both synchronous and asynchronous in the same form. And to some people, like at first I'm definitely still on the async await train. I love it to a lot of degrees, but I'm starting to lean away from it a little bit because it does seem a little bit hacky, and I'll explain that in the gotchas and caveats section, especially like error handling with async await. I'm not a huge fan of personally. But yeah, TLDR, it is part of JavaScript. It is core part of JavaScript. So it's not like a third-party library that you have to install, but it does seem a little bit hacky.
Because just from the syntax alone, it just looks like somebody like figured out how to get a promise working without promises being big. Like promises are a part of this. But do you know what I'm trying to say? It's almost like someone was like, oh, it's version 1 of promises and version 2 looks so promising, if you will. Yeah. but let's get this async await thing working in the interim. That's just what it looks like. That's not the origin of it, or maybe it is, but like, I don't know the history of it, but like, that's just what it looks like to me.
Yeah, it's to avoid nesting, essentially. Like, it's to avoid the hell of like having a million different nested loops or nested promises. And that, to be fair, that does look really bad when you have like a bunch of thens after each other, and figuring out, like, again, it is top to bottom, but it is a little bit confusing how they run and what triggers the next one to run and stuff like that. But sometimes it's good. Sometimes it's better to be more explicit and use the original syntax as the way that it should be. And sometimes it's better to use a combination. Like, a lot of times I will use both awaits and traditional promise resolutions, like an all settled and stuff like that. Like, so like, I like the combination of these two to make it both readable and performant and like less hacky. With that, let's just quickly go over a summary of here, like, why use async over sync. We've talked about it multiple times. Performance is the number one reason. You don't want to block the main thread as much as you possibly can. Stop blocking the main thread. So that's really, really important. Being able to scale. So again, doing stuff in parallel, doing stuff outside the main thread allows you to do more things, right? So if you're only stuck to one thread, you're very much, and obviously the biggest one, and this kind of ties into performance, honestly, is improved UI experience. So like, having the different states of a promise, you're able to tie into those states and be like, well, while it's settling or while it's pending, you can show a loading state, right? Like, you're able to show different UI elements based on the state of a promise or the state of an async await. And that provides a better user experience. Big thing here I want to talk about is some common gotchas and caveats. Error handling is a little bit complicated with asynchronous operations, right? Because again, they don't happen top to bottom. They happen whenever they do happen. It is indeterministic, and you need to somehow catch those errors and show them to the user, or make sure that the app doesn't crash if an error happens. So getting through and figuring out the different ways of error handling, for instance, in promise is the .catch. And then in async await, there's an additional way to catch errors, which is using a try-catch statement. So a try-catch statement is essentially you wrap the whatever you're awaiting in a try, and so it's going to try this. If it's fine, perfectly fine, it's going to continue on to whatever's after the try-catch statement. But if something happens and it errors out, you have a separate statement there called catch, and you can run a console error, an alert, a toast, whatever you want to do. You can catch that error and do something with it, right? So good solution, but it does look a little bit disorienting when you have very large try-catch statements, and it becomes a little bit complex about like, what do you wrap in this try-catch? Is it like, what if you have multiple promises? Do you wrap everything in a try-catch, or do you wrap each one in a try-catch statement so that you can be more direct with your error statements, right? Like, if this one fails, you want this error. If this one fails, you want this error. Well, you can wrap them both in separate try-catch statements. You could wrap everything in one try-catch statement and then just parse the error. And like, it just introduces a lot of complexity that maybe just a simple .catch statement on that particular promise might be easier to work with. But even then, again, you have to understand what the error you're getting coming back. The error that you're receiving back is, and a lot of times with like an API call, that error is pretty indeterministic. Like, it could be an error from the browser, so you have to catch that. It could be an error from the server, you have to catch that. It could be an error from the API, where like you've exceeded your quota. You have to catch that. There's just a lot more to think about when you're trying to do these asynchronous operations and provide a good UI experience and a decent experience to your user so that they know what happened. Mixing async await with traditional promise methods. I mentioned that I do that a lot, but that can be pretty complex. So I recommend learning again how to do that properly. It's nothing too crazy, but it's probably something you're gonna have to rely on quite heavily. Just knowing that, like, if you have a .catch with the traditional promise method and then you have an async await after it, it could get a little bit hairy on how that looks from a dev, like coding readability perspective, and from an error handling perspective, could get kind of crazy. Debugging asynchronous code can be a challenge because obviously if something can take a couple minutes to resolve, triggering an issue with that could be indeterministic, and you can have an issue with just triggering an error. right? Like a lot of times, anything that's indeterministic introduces potential race conditions, which are conditions where like two things can happen at once or out of order, and therefore can screw up your operations because you don't know what's happening first and what's happening second. So you might need to take that into account. It could be that you just can't trigger that error because it's only happening on slow connections and you weren't able to figure that out because, again, depending on whatever timing of your API, it's just debugging in general with async is going to be more difficult than a synchronous regular calculation, for example. Proper usage of await inside loops is a good one, actually. So I believe you can't use await with like a dot map. You have to use a for loop and then you can await a for loop. So there's different caveats on how you can use async awaits with traditional JavaScript structures that you need to learn about. So that there's, again, little gotchas and caveats that you have to be aware of. And overusing async await, I mentioned before, this is a pretty big one. If you have many different async awaits in your code, then yes, you're not blocking the main thread, but you're also waiting for each one of those to happen before the next part of your code can run. And therefore, it can extend a function time quite significantly without optimizing, running in parallel or making it so that you don't need to do so many calls because you only need a certain amount of information. So just understanding how you can make your code better or where the issues can arise is going to help you write better code, essentially. And then quickly to end off here, what I want to do is just talk about some best practices with writing async code. Obviously, keep async code as modular and maintainable as possible. Like, don't have 15 different async awaits inside of one block. Rather, extrapolate and have break up your awaiting infrastructure into multiple different functions. And so that's a little bit easier to maintain. It's a little bit easier to read. You don't want to have a million different ways that you're getting data in one function. You want to break that up as much as possible and only use the ones that you need. Error handling, use the proper error handling strategies. Make sure to use the dot catches. Make sure to, if you're going to use async await, make sure to wrap them in a try catch, by the way. I kind of said that haphazardly in a sense of I'm not a huge fan of that infrastructure at this point or that methodology. But if you're going down that route, you still have to use it. If you don't wrap it in a try catch and it errors out, it will break your application. Just full stop. So you need to wrap it in a try catch. It is a requirement to a certain degree. So make sure to use the proper error handling strategies of whatever promise or asynchronous methodology you're using. Avoid nesting asynchronous functions necessarily. So again, the callback hell, the then, the nesting of then statements, the constant awaiting inside of a single function, all of that is a way to nest asynchronous functions and something that you should really consider refactoring. When you have let's say 3 dependencies in one function, try to think of a way to have a middle layer that can combine 2 of those dependencies or 3 of those dependencies where you can just rely on an external function that will do that work for you and not be done on the front end. Utilizing stuff like promise.all and promise.all settled properly, right? Learn the functions that promises give you and use them when appropriate. And testing asynchronous functions correctly. This one's a big one. Kind of complicated to do. Again, not something I can cover on a podcast, but unit testing a asynchronous function is a little bit more complicated than unit testing a regular function. Because again, you're introducing an element of unpredictability, and what testing typically thrives on is a predictable input and a predictable output at a predictable time function. Whereas asynchronous functions have an issue where you can have a predictable input and a predictable output, but the time function can scale, and even the output can technically scale. So you have to make sure you understand exactly what outputs you can have. Again, all the error statements that can happen inside of a function call or inside of a data call. There could be a lot, right? All the different error codes that you can have, 404s, 500s, all that. You need to understand those correctly to be able to catch them correctly and to be able to test them correctly.
I wanted to ask a question here, and I want to let you go through the gotchas and all the best practices, because when you were going through the gotchas and the caveats, it sounded to me like a lot of the sort of error handling, a lot of the way to write these things, short of the correct syntax, was sort of more like an artist painting, an artist interpretation, where it was sort of like the developer is making their own methods, is choosing their own ways. Like, oh, I'm going to combine async await with these promises. I'm going to have this, like, this is my standard way of doing errors and things like that. But then when you get into the best practices for writing async JavaScript sort of mini section there, it sounds like there is like a proper way to do things. And obviously there's some things that you should not do, some things that you definitely should do. But am I wrong in my first interpretation? Is like sort of the asynchronous handling kind of up to the developer and should be up to the developer, short of obviously some exceptions of, hey, you should do this, hey, you should not do this. Is every developer a little different in how they handle this stuff? Is this stuff, am I correct in assuming it's a little more abstract?
Yeah, it is a little bit more abstract. Like, for example, error handling is a pretty abstract thing that people will fight over on how to do proper error handling. A lot of times people will be like, well, just, put it in a try catch and then handle every error around every function, or do a try catch for every function and just specifically do an error for that. A lot of times errors can be handled with like a generalized error catching function outside of your application even, or outside of your like whatever function is running. You can have like essentially an error catcher that will take an error, any possible error it gets, it will parse it to a certain degree and then output whatever you need it to do. Like, this error needs a toast. This error needs a on-screen, notification of some sorts that's not a toast. This error needs you to take a person back in and navigate them to the homepage. This, you know what I mean? Like, the complexity comes in to the complexity of the application. If you have an application with authentication, that obviously adds another complexity with like, there could be unauthorized errors in some of these function calls. So you need to catch those. And then if you have an application that has like uploading of data, so you need to worry about people uploading malicious data. So now you need an error catcher to detect that and then display that error. Like, it scales with the complexity of the application. And every time you add any complexity, all of these methods of doing asynchronous JavaScript, particularly error handling, I keep emphasizing that because that's the toughest part, because there's so many different variations that could be, also scale with complexity. And you start a lot of times you start like a console log with the error and that's it, because you think it's going to only happen once in a while and it's not a big deal. And then eventually you start noticing that your users are hitting issues, they're not getting them propagated. And then you start sometimes overcomplicating, sometimes properly complicating the part of asynchronous that is complicated. So yes, to your question, where it is kind of a painter's canvas. And a lot of times this is the stuff that people argue about, where like, this is the better way to handle it. This is a better way to handle it. Are there standards? Sure. But the standards are argued over as well.
Because I do hear a lot, and I don't know if it's necessarily specifically about error handling, but I do hear a lot about the arguments of which one of these methods, like async await, callback, or promises. I hear a lot about, do it this specific way to improve performance. Promises are bad for performance, do this. Oh, promises are the way to do it, this and that. And I know this isn't necessarily the performance episode necessarily, and we're getting all into that stuff. However, like, the error handling, like you mentioned, was the most abstract thing that we were talking about in this episode. But just having seen like bits and pieces on the web over the years about this stuff, when I don't do it all the time, it sounds like, just even choosing different methods of like, okay, I'll use a promise here, I'll use a callback here, I'll use this and that. It's like it does seem to sort of be like everybody in this forum post has this working, but they're all still sort of arguing or debating over which one's more performant, which one's the better way, which one's more organized, which way is this. And I would imagine this is why you see error handling, and this is not necessarily even JavaScript, but this is why we see error handling so different in something like a mobile app, where mobile apps rely on so many APIs because a lot of them are communications based, and so they're talking to remote servers left, right, and center. And sometimes you'll see things that just say failed. Sometimes you won't even see an error, and your program will just like randomly not load stuff like the thumbnails. Other times you'll see things where it's like, hey, there's been an error, click here to send the logs to the dev. Like it's so different in every single case. Meanwhile, the actual, thing that's failing is, this API that renders presents my thumbnails in my grid of images or whatever it is it failed, right? And it's like 3 different devs would handle that error 3 different ways. Show the user a bunch. No, don't show the user anything. Make sure you have a log file. No, don't worry about the log. Just have, you test it yourself. I'm sure there's just so many different ways to handle this stuff. So how would you, like, kind of as a brief kind of, I guess, follow up or like finale question is, what would you say to like the person that's bumping up against this asynchronous synchronous wall? Like, again, we've mentioned you naturally hit a limitation in your program that you're making is at a complexity level, at a part where a feature needs to understand or handle the fact that something's asynchronously or synchronously happening. And they're like, okay, I have to look into how to handle this. Like, should they be starting in like the most textbook examples? Like, I would imagine that's how it is, right? And then they'll come up with their own preferences as like, you know what, I've been doing things sort of the most textbook way possible in literally like the promise syntax. The heck with this, I'm going async await, or the heck with all these catches, or the heck with how these errors are handled, I'm going to go do it my own way. Like, do you think that abstract part's more of a natural thing and everybody kind of starts, I guess, in like the textbook method?
I don't think anyone starts in a textbook method personally. I think people start chaotically. Like, a lot of times, whether this is right or wrong, the way that people get through that wall that you're mentioning is with the approach of make it work, make it right, make it fast. And with asynchronous, this kind of does resonate quite a bit, where like, just get it working, make sure it's not destroying anyone's experience. If it's a little bit slow, that's fine. If it's a little bit dirty, it's okay, but get it to work, like make it work. And then move on to, okay, now maybe I should rewrite this, refactor this a little bit. Maybe I should, instead of using all these callbacks or whatever, instead of nesting everything, maybe I should do one bigger function or something, whatever, however you want to do it, clean it up. And then you'll bump into maybe, okay, now I'm on Vercel. I'm hitting the limit for the pro plan. My functions are taking a minute long and it's eating my bills. Make it fast. Now, I say that with a caveat because the complexity here can scale quite a bit. And if you just make it work and it doesn't work well, it could be a pretty detrimental factor to a user experience, or however, like it's one of those things that you have to really determine what make it work means in this particular scenario. Make it work should mean that a user can use it without not severely, but without degrading their experience using the application. If that's the case, you've made it work. If it can be a little bit faster, okay, that's fine, but it's not going to change a person's experience. It's going to just make it slightly better, right? As long as the experience is good with what you've created, and as long as the security around it is also okay, right? For the 99% to the best of your ability, then you're okay, right? If you haven't caught every single error and an error shows up once every million clicks, that's going to happen, and that's okay. Like, I think getting caught in like making sure that all of your errors are perfect from the first time that you hit this wall is going to stop you pretty quickly. So just get it to work for 99% of people, or even 95, whatever you want, whatever you account for the success, and then start adding in those error catches, make it better, right? Make it right. And then start optimizing.
Essentially respect the user's UX.
Yeah.
Like, respect their UX, make sure things are working properly to the best of your ability, and then you'll, come up with your own methods and ways to, improve that. Let's say you take the 90%, like you said, 90% of users are getting the absolute best UX. It's like, okay, well, let's improve it or make it perfect as possible for the other 5. And maybe the other 5% are in like some weird edge case where they only have like 3G internet or something. It's like, okay, maybe we can add some other things that like loads like a lesser API or something like that, the kind of the natural progression of an application, I would imagine.
Mm-hmm.
But I mean, I think that sums up asynchronous, synchronous JavaScript as well, with obviously a focus on asynchronous. I don't know if you have anything else to add, Mike.
I think that's it. Like, I mean, of course I have more things to add, and I would love for maybe a companion piece to this to come out where we talk more in depth and have more examples, because I think the best way to learn this stuff is to see it and use it. You can only do so much in an audio setting. But the goal of this podcast is to, again, give you a high-level overview of what exists, and for you to then take that information and go to MDN to look at what promises are, how promises work, how the proper structure is. Go on ChatGPT, query ChatGPT about how to properly write this promise. Like, ask it, here's my problem. Can you write it so that it's not blocking the UI, right? Like, understanding those keywords is going to make it easier for you to A, search for the right solution, and B, come up with a better plan moving forward of how you're going to tackle these kind of more complex problems in JavaScript.
Yeah, I feel like once you start hitting this stuff and you kind of master this stuff as well, you can almost make anything in vanilla JS, specifically speaking. Like, this is definitely more advanced. This isn't something you're going to hit on your first, like if your entire learning journey is 3 months, you're probably going to hit this at the beginning of month 3, I would imagine. This isn't like, simple or even intermediate JavaScript. And obviously there's edge cases to that too. Like, if you have a very specific thing you're trying to make, sometimes it requires specific timing. But a lot of programs, especially if you're just trying to code up some sort of simpler website or just kind of manipulate the UI, which is commonly what you'll do in JavaScript in the beginning and throughout your career, usually you don't need to do much care, have much care with synchronous and asynchronous. Well, if you enjoyed this episode, remember that you can support episodes like this, and that is on Patreon via patreon.com/HTML, all the things. And many thanks to our $3 tier patrons: Tim from the Web Hacker on thewebhacker.com, Jason from Geek Life Radio via geekliferadio.com, Garrett Segal, Level Up Financial Planning via www.levelupfinancialplanning.com, Magnus from YesWeb via yesweb.se, Syntaxify from the HTML All the Things Discord server, and Stacy Mosteler from swoonworthydesigns.com. And if you have any suggestions on future episode topics, just like this episode kind of was spawned from that, you can reach out to us on htmlallthethings.com on the contact page, where we have an email form you can write in. And we'd also like to give a shout out to Michael LaRocca, a contributing author on htmlallthethings.com. Michael is the author of Self-Taught, the X Generation blog at selftaughttxg.com. Feel free to leave a comment or review in the platform that you are listening to this on, and we are signing off.
You've been listening to HTML All the Things podcast. Web development, web design, and small business. We hope you've gotten some useful and practical information from this show. And we hope you appreciate that we talk to you like human beings. And we hope you had some fun. We'll be back soon. But in the meantime, hit us up on social media on Facebook, Instagram, and Patreon at HTML All the Things. And on Twitter at HTML Everything. Until next time, this is HTML All the Things, signing off.